Good evening. I'm not sure when you're watching this video. This is your lesson video for 11.4. We're now starting the sections where we're going to focus our efforts on volume, and we're going to start off our efforts with prisms and cylinders, just like we did in 11.2. You have no formal homework this evening other than completing your Ed puzzle. However, tomorrow I am going to assign the 11.4 Math Excel, which will be due Wednesday. So if you have an interest in getting started on that, because you know you're going to have a lot of homework, please feel free to do so. We do have our Chapter 11 test scheduled for May 17th, and please continue to be working on your final exam preparation by rewatching lesson videos, retaking notes, and starting those review problems. Here we go. So what is volume? Volume is the idea that it's the amount of space that a figure occupies, okay? And the big idea that I'm going to have to be keeping an eye out for when I'm grading your quizzes and grading your tests is your unit of measure, because now we have volume, and volume is going to be measured in cubic units, whereas surface area was measured in square units because it was an idea of area, okay? The probably easiest figure for us to ever find the volume of is probably that of a cube, because we know that we have all three side lengths are the same measure. Therefore, you have been taught ever since you were in a very young age just to cube the measures of the edges. Okay? The big idea that we need to understand is as long as we know the height and the base area of a prism, we are able to find the volume, okay? Let's take a look at these two stacks of Post-it notes. I'm sure you've played around with Post-it notes before and you've tried to push them over to the side. When you push them over to the side, you do not modify the amount of Post-it notes that there are. The other thing you don't really modify is the fact that they're going to have the same height. The Post-it notes are going to be an example for us of a right prism versus an oblique prism. Please recall with oblique prisms, when we measure the height, we always measure the height as a relation to the ground perpendicular, and of course that was not a straight line, but that's okay. And the idea that I want to take away is because these stacks of Post-it notes are the exact same, they have the same height, and each of those Post-it notes has the same area, aka each cross section has the same area, then these stacks of Post-it notes are maintaining their volume. They have the same volume. What these Post-it notes are illustrating for me is called Cavallari's principle. And in Cavallari's principle, what it says is if two space figures have the same height and have the same cross-sectional area at every level, for example, all those red Post-it notes at that level have the same cross-sectional area, then we can conclude that they have the same volume. Now, this does not only apply to right prisms versus oblique prisms, this also applies to other shapes. So I have three shapes here, and they all have the exact same height we could observe. And the other thing that they have in common is if I were to actually go through the effort of calculating all these cross-sectional areas, they'd all have the exact same cross-sectional area. And because they have the same cross-sectional area and the same height, we can conclude that all three of these shapes, while different, have the same volume. Okay? Alright, so my big idea, I need to know how to find the volume of a prism. As we've talked about, it is just the idea that you find the area of the base and multiply it by the height. Okay? So here's our first example. We are going to find the volume of the rectangular prism here. Alright, let me write my formula out. Volume equals base times height. Please remember the base is dependent upon what shape you are dealing with. Okay? Now I have a rectangular prism here. So the base of my rectangular prism is this rectangle. And I have been taught, ever since I was in middle school as well, that to find the measure of the area of a rectangle, all I need to do is multiply its corresponding length and width. So we have 24 times 20, representing the area of our base. And we're then going to multiply this by the height, which is 10. Okay? The reason why this works, if you can imagine, is you're taking all those areas and you're multiplying by the height because you're stacking up several areas occupying that space. Alright, so in total, when I do 24 times 20 times 10, I'm going to get a volume, I believe, of 4,800. Now, just like I was warning you with surface area, you need to make sure you include units of measure. And we are dealing with centimeters, and because I'm dealing with volume, I'm dealing with centimeters cubed. Here's your got it. You are finding the volume of this rectangular prism, and then I have a reasoning question for you to also be thinking through. Alright, you should have gotten this as your answers. 60 feet cubed. If you did not, please make sure you check your work. And also, does it matter that we turn a prism on its right, changing the base to becoming the 4 by 5 at the height of 3? No, the volume does not change. It's still going to maintain all of those components that we would use to calculate our volume. All right, let's get a little bit more fancy. Okay, cover up that guy. Don't get too excited for yourself. All right, what is the approximate volume of the triangular prism? When I am told I have a triangular prism, I need to remember that my bases are triangles, okay? So this is a base and this is a base. And an idea that I learned at the very beginning is that bases are parallel and bases are congruent. So what I can do is I can pull this unit of measure of 8 to this side here. So I need to focus my efforts on my base. And my base is an equilateral triangle with sides of 8, 8, and 8, okay? And something we talked about in chapter 8, ironically, is the fact that we can take an equilateral triangle, divide it into 2 triangles, and these 2 triangles that we divide them into become a 30, 60, 90 triangle, which is what we need, because to find the area of the base of a triangle, we need to do 1/2 the base multiplied by the height, okay? In this scenario here, the height's going to be 4 root 3, because we know that the short leg is going to be half the hypotenuse, and the middle leg is going to be 4 times root 3, okay? All right, so now we can find the volume. Volume is equal to the measure of my base. We're going to have 1/2. My base length is a length of 8, and the height for my base is a height of 4 root 3. And I'm going to multiply this by the height of my prism. And the height here is 10 inches. Notice that once again is that segment connecting our 2 bases, okay? And I understand that we are asked for an approximate answer, but I'm going to make sure I teach us how to really get good at finding exact answers. So I'm going to do 1/2 of 8, and that's going to be 4. So we have 4 times 4 root 3 times 10. 4 times 4, that's going to be 16. So we have 16 root 3 times 10. And then all I can do is multiply the 16 and the 10, getting myself 160 times the square root of 3 inches cubed, okay? This is an exact answer, okay? An approximate answer is if I were to type this into my calculator, and when I type this into my calculator, I get an answer of approximately 277. So 277 inches cubed. All right, your turn. You also have a triangular prism, and you also need a reasoning question. It helps with these reasoning questions that you actually go through the math to see how volume is affected. Solutions have been provided. This is how you should get your answer of 150 meters cubed, okay? Please note that this is the measurements you would need to find the area of the triangular bases, okay? Probably should move this up so you can see the measurements if necessary. And please note that if the height of a prism is doubled, because this is one of the measurements that is just one of the pure components of volume, this is also going to affect our volume and it's going to double it. All right, that concludes prisms. Let's move on to cylinders, okay? So to find the volume of a cylinder, we're going to use that same formula of volume equals base times height. However, we need to recognize that the base of a cylinder is a very specific shape. Because they are circles, all we need to do is use the area formula for a circle, which is pi r squared. And if we extend that idea, that is where we obtain the fact that the volume is equal to pi r squared times the height. Once again, representing that if you take that volume, the area of the circle and just stack it up on top, that is why you are multiplying it by its height, okay? All right, here's my example. We need to find the volume of the cylinder in terms of pi, okay? I'm going to write down my formula for myself. Pi r squared times height. All right, we know pi is going to be a component of our answer. Looking at my diagram, according to my diagram, the radius of the base is going to be 3. So we're going to have 3 squared. And we're going to multiply this by the height being 8 according to the image, okay? And I'm going to start to simplify this. We know that 3 squared is 9, and then we're going to have to do 9 times 8. And I know why. 9 times anything. So we know 9 times 8 gets me 72 pi. Okay? Now the only thing I'm missing from my answer is that unit of measure, so we need to have centimeters cubed. Okay? Also, I'm a little panicked. Did I put it on the last page? I should probably check that. Oh, good. Miss Rudolph did. All right, you got it. Your turn to deal with some cylinders. Once again, please remember, Cavalari's principle says it does not matter that we have a tilted cylinder, okay? You are still going to treat it the same way. And again, you have a reasoning question to try out. Solutions that you should have found that the volume is 3 pi meters cubed. And you should have found that when the radius of a cylinder is halved, the volume is actually going to be cut into a fourth. The reason being is because of that volume being pi r squared multiplied by the height, because you're going to be squaring half of the amount that you had. When you square half, you get a fourth. Last one deals with the idea of composite space figures. Now, a composite space figure is just a three-dimensional figure that is the combination of 2 or more simpler figures. We can find the volume of these figures by simply adding their combined volumes. Okay? So what I have for us today is a fish tank. Okay? If it is helpful to you, I have a little video to illustrate how we can break apart the fish tank. Okay? Open this up, press play. So here's my fish tank. Take away the fishies, start to break apart what I see. And right now I'm kind of seeing a prism, and it looks to be like half of a cylinder. Okay? Now, if I start to pull it apart, which I'm hoping my video does any second now, there we go. We recognize that we can take part of that measure of 24 and divide it in half to recognize what the radius is going to be for that half cylinder piece. And we notice that the radius is going to be 12 for that cylinder piece. Okay? So while I'm splitting these apart, I'm also maintaining the measurements that will be necessary when breaking these apart. I'm also noticing that that 24 inches that's representing the height of that prism, I'm also going to pull over eventually too. Okay? Now the other piece I need to identify is what this prism length is going to be. Now because the ultimate length is 48 inches and the radius was 12, I can break apart that prism and recognize that this prism is only going to have a length of 36 inches. Okay? So I believe we have all the information. Perfect. Okay, and let's pull out what the figure we discovered. All right, here we go. So we need to find the volume of both of these figures. So let's first find the volume of the prism. Okay? To find the volume of the prism, we're simply going to do 36 times 24, because that's going to be the dimensions of the base. Multiply that by 24. Okay? And what I find for the prism's volume, if I make sure I have that number correctly, we have 20,736. 20,736. The next piece I need to find is the half cylinder. Okay? So volume for a cylinder is traditionally pi r squared times the height. Now I only need to worry about half of that because I only have half of a cylinder. Alright, so now I'm just going to fill in pieces that I know. We figured out that our radius is going to be 12, so we have 12 squared. And the height is maintained. The height of this fish tank is still 24. Okay? Alright, so half of 24 is going to be 12. So we have 12 pi times 144. And then we just need to do 144 times 12. And we're going to multiply that by pi as well. And I'm going to get an approximate answer here. An exact answer, of course, would be if I left this in terms of pi. My approximate answer is 5,429. And the last thing that I need to do is recognize that I need these two volumes to be added together. So I'm going to add 20,736 and 5,429. And when added together, I get approximately, put my approximate symbol here, 26,165, and I got to remember my unit of measure here is inches cubed. Here is your final got it. You are dealing with a lunchbox and finding the approximate volume of the lunchbox. That can kind of be helpful to figure out how much food you could fit in your lunchbox. Solution is now provided on the board. Your total volume is 360 plus 45 pi. This would be an exact answer, maintaining the precision that you need. And then if you need an approximate answer, you have 501 inches cubed. All right, guys, have a great day.